We honored to have Baldev Raj Narang, CEO, Clariant Power System Ltd. Baldev Raj Narang is the CEO of Clariant Power System, brings 45 years of experience in the public and private sector. He leads the company in offering global client reactive power and power quality solutions. As chairman of the CAPQ division in the EMA and member of the BIS ETD 01 committee and IEC TC 08 WG11, he shaped the power quality standards. Today, Mr. Narang will talk about renewable energy integration and power quality.
I'll be talking about grid stability in the wake of large-scale RE penetration in the system. And I'll be also talking about the power quality issues. What we have today, the world is warming faster than at any time in the history today. And the weather patterns are changing, balance of nature is disturbed, and we see floods, we see tropical storms, we see droughts, wildfires, and all that. And this is all, maybe we have to have very stringent targets, which already have been set by the Paris Convention. And RE integration, RE penetration is supposed to be the major, you can say, activity, which has to give us these targets. We have to increase our RE generation in India from maybe almost 3 times, 170 gigawatt to 500 gigawatt by 2030. Worldwide, it has to increase from 3,500 something gigawatt to about 11,000 gigawatt. The carbon, you can say, footprint also has to go down. It has to go down by 45% by 2030. And then the global warming target also is very stiff. It has to be 1.5 degrees by 2040. So these are very stiff targets, very challenging and very ambitious. And there is no alternative. We have to get them so that we save this planet for our future generations. And RE integration, the RE penetration is supposed to be the major driving thing for all these, you can say, achieving these targets. And not only these targets have to be achieved, this thing, you can say, generation has to go 3 times by 2030, but also the efficiency, the utilization also has to double. We have to have various measures in this thing. The efficiency has to go up, and maybe the plant load factors have to improve. The government PLI schemes, all the things have to be in place so that we get to these targets. And in this thing, means we have to get help from solar, the wind, the hybrid, the pumps, hydro, all these things have to contribute. And what is happening is today, because of this large-scale integration into the grid, because we are adding the system, the conventional plants are being phased out. And we are facing problem of the grid stability. There have been interruptions in the past. In the year 2022, we faced about maybe 28 or something interruptions where more than 1,000 megawatt was lost. The RE was lost. And that was because the system, the grid is not able to handle this, you can say, penetration. The increasing RE penetration is not being, maybe the planning somewhere, something is lacking, or we are not prepared for the, you can say, things. When we are adding the things, we have to take many measures which are maybe not in place as on today. So what is happening is grid inertia. These RE plants are coming in remote locations where the grid inertia is weak. The short circuit ratio is very poor, about 5 to 10. The faults are not cleared in time. And there are conditions like LVRT, HVRT. We need reactive power. The voltage support is required, which is lacking in dynamic conditions, maybe static conditions, both. We have switched capacitor banks, switched reactor banks. We have even the STATCOMs, which everything works in steady state conditions. But when it is a dynamic condition, the fault conditions, nothing is working. And maybe there have been some mandatory requirements set by CEA saying that we need STATCOMs to overcome these problems of grid stability. The loss of, you can say, stability is there, and that they think maybe STATCOM will be able to supply the reactive power required to maintain the voltage within time, and it is always better than switch capacitor banks, switch reactor banks. But it seems the solution is not so simple, and this is not a magic solution. We need much more than that. we see that our inverters go into oscillation mode. They are not able to support the things, and we have these issues coming up. So what is the, and this is not the only thing, not only the voltage stability. We have to have the, you can say, grid strengthening. The inertia has to be increased. The grid inertia at these remote locations is not there, because the conventional plants which provide the inertia, they are not available at those locations. So what we have is very weak grid, very weak inertia, and we need a grid forming inverters. We have so far grid following inverters which are not able to support the grid. The inertia is weak there. So that is one thing. Or maybe we need synchronous generator. So we need pump hydro or something like that. So this grid inertia has to improve. Otherwise, we will keep on adding the things and we will land into instability, which is happening today. So all these things have to be looked into. We have a very big challenge at our hands. We are adding, you can say, the great RE plants, but we have to see that we have the transmission facilities available to maybe evacuate this, whatever is generated. The demand is also there. So a lot of things have to fall in place. And still we don't have maybe the regulations, the you can say this, whatever is required to achieve these things. They are still in the formative stage. We have yet to they are in place so that we have the stability. In future, have more integration, we'll have more problems. Right now, the integration is very limited so far. Maybe although it has gone up much in last few years, but it is going to be 3 times of today what we have. So we should understand the scale of addition. So that is what. And one more thing, what we have is the power quality, which I said I will talk about the power quality also. The power quality is also going to be a very big challenge, because when we are adding these wind plants, we are adding these solar plants, what is happening is we are creating very high level harmonics. Normally we have harmonics of the level of 5th, 7th, 11th, 13th and all, which are very easy to tackle, very easy to manage by passive means or active means. But these high level harmonics, they don't have the standard solutions. In fact, there is nothing available today in India. No plant seems to have any solution for tackling harmonics beyond maybe 23rd or 11, or maybe 21st or up to maybe 49th harmonics. So they have to be tackled. Statcoms are available, but they can tackle only up to maybe 17th or something. But we have a statcom with Clariant, which we are supplying, which can tackle up to 23rd harmonic. Then we have passive filters, we have C-type. So these things are now being mandated. The CA is asking that we maintain power quality. They are asking that we maintain the voltage level. We maintain 1/3 of the reactive power support in the form of dynamic compensation as a statcom they want. But all these things are to be there in place, and they have to physically perform. In the performing stage, we don't have, you can say, the power quality measures. The statcoms have yet to come. There is, I don't think there is any statcom installed at 33 kV level. All these things are coming at 33 kV level. And we don't have anything in a state where it is functioning and it is delivering the result in a dynamic condition. So all these things are just on the paper only. So let us see how we manage. We are supplying statcoms. We have the confidence that we'll be able to do it, and we'll be able to maintain the voltage stability also. We'll be able to supply the reactive power in time. We'll be able to maybe give the harmonic mitigation systems also as required. So these are certain things, challenges which we see in future. And this is a very big challenge. And what we have to see is that we don't have these roadblocks. We don't have any, you can say, issues coming. And we the regulations, they are one of the most important things. We have yet to frame the regulations and the quality of the systems. Maybe one thing which I am very much worried is the quality of the inverters, the grid inverters. They are not up to the mark what we have in India, and they are creating a lot of issues as on today. So, and not only the inverters, in fact, everything has to be up to the mark. And when we are talking of such big things, we have to see that we are prepared for that. We have the quality measures. We have the maybe measures for manufacturing all those things. We have the manpower. We have the training of the people. And these are very big challenges. And we hope that we are able to overcome them and we are able to manage the situation. I think this is just briefly I have told about the grid stability, about the harmonic issues, about the power quality issues. And if there are any questions, I can take up later on during the maybe session when we go. I don't know whether I have taken sufficient time or maybe it is okay.
Thank you, Mr. Narang, for sharing your views on renewable energy integration and power quality.